Dear students, so we start a very important module today, the discrete Fourier transform. You know that the Fourier transform for continuous time signal is given by this expression. So for discrete time signal means when the signal becomes discrete, it can be represented as this equation. Look, this part of the equation, that is n is equal to here integration is minus infinity to infinity. So here I take the summation since it is discrete. So summation of n is equal to minus infinity to infinity xn e to the power minus j 2 pi by n, that is for omega. Omega is equal to 2 pi by t, that is why we are taking it as 2 pi by n, where the capital N is the number of samples and this is represented with n into k. That is, n is the particular sequence of the xn sequence, and k is the xk, that for what we are computing. This is a very complex calculation, so we represent it as a Tweedle factor given with this one. So the Tweedle factor is given as e to the power minus j 2 pi by n into k. You see, if you compare the small n, the capital N is the number of samples, so we write it as capital N, and n into k is given over here. So what is its purpose? Let us see. For a 4-point DFT means we are having 4 samples, that is capital N is equal to 4. So this is the Tweedle factor chart. You see, we know that that this part is plus 1, this is minus 1, this is plus j, and this is minus j. I write it as W40 is equal to plus 1, W41 is equal to minus j, W42 is equal to minus 1, W43 is equal to plus j. Then W44 is again plus 1. So the circle is going in this manner, that is in the clockwise direction. So let us see how do we compute W4j, that is e to the power minus j 2 pi by n into k. Here capital N is the number of samples, here it is 4, and n into k is 0. So it becomes W40 is equal to, that is n into k is 0, that is W4k becomes the W4, that is this one becomes 0. So e to the power 0 is equal to plus 1. You see over here, W41 e to the power minus j minus 2 pi by 4, the e to the minus j 2 pi by 4 into 1, that is e to the power minus j pi by 2, that is cos pi by 2 minus j sin pi by 2. So W41 is equal to 0 minus j into 1, that is minus j. You see over here the previous page, W41 is equal to minus j, and you see over here W41 is also is equal to minus j. Similarly, we can compute the other parameters W42, W43, and the other factors can be computed. So let me take an example to explain you the problem. Xn is equal to, suppose this sequence. I have a sequence 0, 1, 2, 3. The arrowhead is given over here. Means this is the position where n is equal to 0. So xk is equal to summation of, for this problem, n is equal to 0 to plus 3 xn e to the power minus j 2 pi by capital N into n into k. So for x0, mind it, this capital N is the number of samples. So here it is 4. This n goes on like this. I come and explain it to you, and then k. So x0 means here k is equal to 0. So how do I compute x0? E to the power minus, the factor is given over here, e to the power minus j 2 pi by 4 into n is equal to 0, and here k is equal to 0. X1 e to the power minus j 2 pi by 4. What is n over here? Small n is 1 and k is 0. Similarly, x2 e to the power minus j 2 pi by 4. What is the small n over here? That is 2, and k is equal to 0. And x3 into e to the power minus j 2 pi by 4. What is n? 3, and k is equal to 0. Here you see, for the first one k is equal to 0, means what it is coming, x0 e to the power 0 plus x1 e to the power 0, like this it is coming. E to the power 0 is 1, so I put it over here, I get the value of x0 to be 6. Now see, the complexion starts from when k becomes plus 1. Similarly, I put x0 e to the here I put all the values. Now see, W40, the first one is W4, capital N is 4 and N into K is equal to 0. X1, W4, N into K is plus 1, W41, X2 is equal to W42, X3 is equal to W43. From the Tweedle factor charts, I get W40 is equal to 1, W41 is equal to minus j, W42 is equal to minus 1 and W43 is equal to plus j. I put the values, I get the results. Similarly, I have computed x2, I have computed x3. Yeah, I think it's quite clear to you. Then, so from there I can conclude that xk is equal to the sequence is like this. So this is for 4 point. Then what do I do for 8 point DFT? Since that was a 4 point chart, this chart, so for 8 point, you need to draw the 8 point chart. It is like this one. So W81, W82, W80, W81, W82, like this it is going. And this is plus 1, this is minus 1, this is plus j, this is minus j, and I have computed the remaining 4 values. So how do I get W81? So W80 I have computed. It is put, I have given the capital N is equal to the 8 and N into K is equal to 0. So e to the power 0 is 1. So W81 is equal to e to the power minus j 2 pi by 8 n into k is equal to 1, that is e to the power minus j pi by 4, that is cos pi by 4 minus j sin pi by j sin pi by 4. What is cos pi by 4? Cos 45 degree 1 by root 2 minus j sin pi by 4 is equal to 1 by root 2. So I get the value 0.707 minus j 0.707. Look, here I get the same value. So similarly, the other parameters can be computed. So I give you a practice problem, this one. Thank you.